Oh, I've got to stop this music, otherwise, in my recordings, it will mute my stuff. I know you can't see it.
Oh, that was dumb. Yeah.
So on this one, there's a max, like number 7 is a max, but no minimum. So when you do shading,
Yes.
does it like matter, or you stop at?
No, actually, on this one, since it's an unbounded region, it is just going to continue on forever.
Okay.
Okay? And I do want to take this time to just kind of clarify what's going on with this no max and this, that, and the other. Okay? Because I didn't really, talk about that very much yesterday. So in this particular situation, all we have is we've got this, and we got that region right there. So that's our only vertex. We only have one vertex, which is kind of odd. Okay? So I wrote that vertex down, found out that it was 13. Right at this point in time, I don't know if it's a max or a min. I have no idea. Okay? So it's kind of like when we were graphing and shading one side or the other, we just had to pick a test point and figure out what was going on. Well, in this particular case, I just picked a test point, and I thought 0, 0 was in that range, so I picked 0 and 0. That told me it was 0. So everything else in this region is also going to be less than that 13. Because this 13 is either a maximum or a minimum. It's either a max or a minimum. And since that's 13 and the other one is 0, then what's this got to be? Maximum. It's got to be a maximum. Because we found another point that's smaller, so there's no way that we can find another point that's smaller and have that be a minimum, so that is actually going to be a maximum. Like if I would find another point, like say over here, 4, -2, plug in 4 and -2, I would get 0 again, which that's kind of surprised me. But so that again is smaller than 13. If I would pick something like, say, way down here, let's go 6, -6. 6, -6 would give me -6. So we can see that as the further I go, it's getting smaller and smaller and smaller and smaller. So then, yes, this is in fact a maximum. Okay? And on 7, kind of the same thing. I picked this point way out here to go with my other 2 that are vertices. That gave me 20. That gave me 30. This gives me 49. So as I keep going this way, it's going to give me even something bigger. So the only thing we have is a minimum that occurs right there. Okay. So 9, I want to talk about 9 just a little bit more. 9 is one of these problems that it didn't intersect at a nice clean point. Well, we're going to start handling that a little bit different way. This point's really easy, but this point, I don't know. I guessed. But do you think we can find that intersection point? Yeah, algebraically. Okay? This right here, this line right here that's intersecting, that's y equals 3x plus 6. This line here is the 4y plus 3x equals 3. So if we combine both of those together and actually solve the system, we can find where they intersect. That's what we just finished working on in one of the last sections. So here we go. I just did it real quick. Y equals 3x plus 6, 4y plus 3x equals 3. I took this, injected it there, solved, and I found negative 7/5, which is negative 1.4. And then I could plug that in, and I can find that that's 9/5, which is 1.8. So if we ever have something that's kind of in the middle, we can just solve the system. Okay. Not a greatly fun process, but we can do that. 10. There's 10. Okay. So this is more the problem style that I really, really like. The equations write pretty nice. Today's are going to be kind of a little bit on the ugly side, but we're going to we'll get it figured out. We're going to work together on setting up 3 particular problems. And then we had one more. This one, the thing we should make is 30 cars and 40 trucks. Not only will that yield us the most profit, but it'll also use up all of our materials. Any combination on this outside will use all the materials, I believe. No, that's the only one that'll yield. Use all the materials. Yeah. And that just so happens to be the one that's going to make the most money. Won't have any leftovers either. One thing that's interesting, on talking about cars and stuff, if you ever have a chance to go to and take a tour of someplace that they build cars, it is really super, super, super interesting. Down in Bowling Green, Kentucky, they've got a museum for the Corvette, and then across the street, they build the Corvettes. And you can take a tour of them watching. You can watch them build cars. It's so cool. It's so cool. And this makes me think of it because they're talking about wheels and seats. What's amazing is that they don't have like 3, 4, 5 weeks worth of wheels sitting there. They deliver them just in time to build the car. All the engines, they deliver them just in time to build the car. All the windshields, they deliver them just in time to build the car. So there's actually a whole theory of supply that's called just-in-time manufacturing. So they'll get it to you right when you need it, and then you don't have to store all those wheels and all those windshields and all the body parts and this, that, and the other. They'll just basically take them off the truck, put them on a rack, use them right away. I don't know. If you're interested in that stuff and you can't do something like that, pull up a YouTube, and it's really, really neat to see it all come together. It's really cool. It's really cool. So, okay. Any of that stuff you want to talk about? Today's going to be all right. The other classes, I think, they did pretty well, and it was kind of fun to get up and out of our seats a little bit. But you need to be able to graph. You need to be able to solve these linear programming problems. So I got 1, 2, 2. Okay. We are going to have. You're going to pair up. Nobody's by themselves. But we do have an odd number, so I'm going to have one group of 3. Okay? So what you're going to do is you're going to need your textbook, okay, or just one for your group. You're going to need a whiteboard marker. You're going to need a section of board somewhere around the room. You can use this, you can erase this testing that I have written there. And you're going to need your phones. Okay?
All of us, or just one per group?
All of you will need your phones. Yeah. What we're going to do today is I'm going to help you guys. Instead of you guys watch me set up your equations, I'm going to try and help guide you guys to setting up your own equations for these word problems. Okay? So, grab a section of board, grab that other person. Everybody's with somebody. Only one group of 3. Go. You don't need a whiteboard. You just need a section of board that you're going to work on. Okay.
What page?
We're going to be on page 123. Ladies, you're going to be working on the board. On a section of board. Yeah, like everybody else is getting ready to write on a board. Okay? Okay. So you don't need a whiteboard. Okay? Okay. So here's what we're going to do. Well, like I said, we are working on writing equations for these word problems. Okay? So here's the deal. The first thing we've got to decide is what we're trying to decide, what we're trying to optimize, and what our options are. So, okay. So here we go. If we just focus on one particular part, here's what it says. Find the combination of clay and glass beads. So we're going to have so many clay and so many glass. That tells us what our variables are. Our variables are clay and glass. Okay? Because we're trying to find out how much of each. Like on the problem you did for today, how many trucks, how many cars. That was our variables. Okay? Here our variables is how many clay and how many glass. So I'm going to try and guide you through this a little bit. And I'm recording, so I'm going to have to kind of camp up here a little bit. This one here, this is different than what we've done before, but it says that for what I've got highlighted there, there's already 2 inequalities you need to write. A jewelry company makes and sells necklaces. For one type of necklace, the company uses clay beads and glass beads. Each necklace has no more than 10 clay beads and also has at least 4 glass beads. Remember, your variables are clay and glass. Clay and glass.
No shot. That just happened. That makes me so frustrated.
And that stuff doesn't come out very well either.
It's fine. I can read it.
Okay.
Okay. Each yeah, so it's no more than 10 clay beads.
So you okay. Okay. So now throw your variables in. Good. Perfect. Okay. So what I'm going to do is after we get this figured out, remember, I'm recording for other people, so I've got to zoom in here so we can show them the answer. Okay? Okay, where are we at here? Yeah, thank you. There we go. So far, it says that C has to be less than or equal to 10, and G has to be greater than or equal to 4. Those are our two constraints so far. Okay? Nice job. While we're here, also write two inequalities that say that they can't be negative. Okay, go for it. Add two inequalities that say that C can't be negative and G can't be negative. No, the absolute value won't work in this case because then that means it can be negative, but that's got to be less than 10. So yes, there you go. You're good. Good job. Keep going. You're perfect. Keep going. Okay, so here we go. There are inequalities so far. C is less than or equal to 10. G is greater than or equal to 4. C is greater than or equal to 0. G is greater than or equal to 0. There are our four inequalities we have so far. Those are constraints. That's a great question. Could it be written like that? Step aside. There you go. Okay. I'm going to say the first one, yes. The second one, no. Because, and this is kind of a complicated thing, but the first one, if I would take out the variable on the inside, this is kind of important for you guys to see this. We were having a discussion in the math department how to teach this. So on your first inequality, if I take out the C, would it be true? 0 is less than 10. Yes. Okay. On the bottom one, so the top one's okay. Bottom one, 0. And if I take the G out, would that be 0 is less than 4 and at the same time 0 is greater than 4? No, we'd have to write that second one separate. Okay? Okay, so here we go. This is kind of fun. Okay, let's darken this up so we can go back and start writing some more inequalities. Okay. Okay. So now we have to write the next one. Okay. And let's focus. I know it's a pain, but I want... Okay. For the next one, it says for every necklace, 4 times the number of glass beads is less than or equal to 8 more than twice the number of clay beads. So write an equation for that next statement. Personally, I think this kind of invalidates this as a realistic problem.
I know that's the question of
Okay. Nice job. You watched that football game last night, Chase?
A little bit.
I loved it.
I couldn't get it. Wait.
The football game?
We didn't get it.
Oh, really? Okay.
There. Boom. Bam.
Okay. So, Kim, can you step aside here real quick?
Yeah.
Okay, good. So the next inequality is going to be 4C is less than or equal to 2C plus 8. Oh, no. There should be... One is a G, though. Which one's a G? 4G, I think. There you go. There you go. That's good. Okay.
Because it's 8 more times than...
Yeah, it's... 4 times the number of glass beads is less than 2 clay plus 8. So now what we need to do is now we need to write a objective function. Okay? So let's go back to here. I'll zoom back in or out or whatever the heck I got to do. And let's write an objective function. God, this is a pain. But I like getting you guys out of your seats and seeing how you're writing these things. Okay? Okay. Each clay bead costs 20 cents each. Each glass bead costs 40 cents each. They want to minimize their cost. Write your objective function, please. Okay. Okay, here we go. We're going to pick a different one. Sorry. Everybody run. Oh, no. I need to just... Okay, that is correct. Okay? Okay, so the objective function here is now 0.2c plus 0.4g is equal to t. Or you can put equals $sign. There's no less than or equal to. That's my objective function. That's how you tell it to your objective function, because it's just equal to my cost. So you'll graph everything else, take your points, plug it into your objective function, and minimize your cost. Okay? So now, how do your phones come in? Well, first of all, write down that's number 11. Take a picture of it, and then when we get you during your homework time, you'll be able to take your picture and then take your phone out and put that picture, all your inequalities, on your assignment. And if you don't like yours, you can take a picture of somebody else's. Wah, wah, wah. Once you have your pictures taken, you can go ahead and erase it. I don't know how to clip anything, so.
Oh, you got you bad. I'm going back to watch that video just to get that.
Okay, here we go. No, we're not. 12. We're just getting started. Okay. I'm going to tell you right now, don't worry about the 8 days yet. Don't worry about the 8 days yet. So 12, write an inequality about weight. I did because they made a mistake. Should be or, and I'll get to that here in just a second. So write an inequality about weight. Yeah, we try and decide how many pots, how many plates. So those are our variables.
So the pot's weight is two. P-T. You can actually more than pot? Yes. Yeah. Yes. Oh.
Yeah, I don't like the variables of this one either. Okay. Just about weight. Just do the weight one first. That's it. Because you're on the wrong track with the rest of it. No. Okay. So here we go.